In previous video, we discussed about the two simple technique regarding to the capital budgeting. One is a payback period, the other one is a discounted payback period. So the decision rule to accept or not to accept is based on if the payback period can be less or earlier than the payback period decided by the manager. The second method, discounted payback period, is preferred to the payback period because they're including the time value money concept. And both techniques are easy to understand, but the serious disadvantage is the bias toward liquidity. And also, this bias can make the company miss some good opportunity to invest in some project that can create a long-term value or a greater value for the company. So we like to present you the net present value. As you can see in the screen, this is the formula for the net present value. Look familiar to you, right? And this part look like DCF model, what we learned from the stock or the bond valuation. Yes, we kind of use the DCF model into the net present value. The only difference is this one. This is the cash outflow. So the cash outflow plus the summation of present value of a future cash flow. So you can see this cash flow coming from 1 period from now, cash flow coming from 2 period from now, 3 period from now, and so on. So you can see this model is totally different from the previous two techniques. It's a little bit complicated, but it's not that difficult for you to understand. They consider all the cash flow generated from the project. So they did not get up those cash flow after the cut-off period. They also take into consideration of time value money. Decision rule for net present value is you accept a project if net present value is greater than 0. So what does that mean? That means this project can create the positive value for the company. So net present value greater than 0, which means normally this one is negative because it's a cash outflow. So that means the summation of present value from all the future cash flow generated from this project can fully cover, or even create a positive value for the company, fully cover this initial investment, and also even can have a positive value. Okay, so the project create a positive value for the company, then you should accept this project. So one key component in the net present value analysis is this R, discount rate. So the discount rate represents the minimum return required for the project. And also, they take into the consideration of the risk for the company to invest on this project. Again, we're using the global wise companies as an example to show you how to apply the net present value to compare the two proposals. So one is a Western Europe project, and the other one is a small scale project in the Southeast US. So in this project, the initial investment is $250 million. And this is all the future cash flow. And the discount rate is 18%. And once we did the calculation, we find out the net present value is 75.3. The second proposal is a much small scale. Apply the same discount rate, and we can get our net present value is 25.7. So now, if you remember, we mentioned about this decision rule. As long as they can create a positive value, then you can accept a project. So here comes the question. Should Global Wireless invest in just one project or both of them? Because both projects can create a positive value. So what's the answer? So the answer you probably will say, it depends. Yes, it depends. So if the company has a lot of money and they can, like for example, this project will invest on 250 million. This one need to invest 50 million. So if the company has more than 300 million available, and they can invest both projects. If a company has the limited financial resource, then they have to decide which project they want to invest. So you can see this project is a larger scale, and they can create more value for the company. So if money is not a constraint, then you probably can take into both, or you just choose this one because this one can create much greater value for the company compared to this small scale. Okay, so let's take a look for the Excel template. How can you use the Excel template to solve this question? So in this slide showing you, you can use your finance calculator to just calculate for this value. So let's take a look for the Excel template. So this is the net present value technique applied into the first proposal in the Western Europe. So similar to the discount payback period, you need to calculate the present value of each future cash flow. So you can using the function, or you can using the present value formula using the future value divided by 1 plus discount rate to the power of the period. Depends on which period you will see this cash flow. Then next step, you calculate the accumulated cash flow, and you sum up this accumulated cash flow. You are different from the previous discount payback period. This one you need to also including the cash outflow, and you sum up all the value of present cash flow together. And if you find this can net present value is positive, then you accept it. You also can using the function in the Excel template and using the net present value function. So you update with the discount rate, and you select all the cash flow, and you can find the net present value for you just using this net present value function in the Excel. So the second proposal is in the US, and you can apply the similar technique. Okay, and calculate accumulated cash flow, and you can sum up all the cash flow together and to get the net present value. You also can use in the net present value function. So net present value is the golden standard for investment decision. So it's the best measure and most commonly used measure. And because they consider about all the future cash flow, and also adjust for the time value money, and also account for all the risk. To solve for net present value, as we show you, you can use in the formula. You can use the Excel, And the most important, you can use the finance calculator. So let's show you how to using the finance calculator function built up for you. So this is TI bar 2. So assuming you have a cash initial investment $165,000. So you press the CF button first, and you enter 165,000 and press the negative, and save your entry by punching this enter key. Here comes the first cash flow. So once you place the enter, your calculator will show C01, so which indicate first cash inflow. So cash inflow 01. And assuming the number is $63,120, so you enter 63,120. And you press enter to save your entry. And it will come up F01. So F, this function to let you to enter if this cash flow is repeated or not repeated. So if it just only happened one time, the default will be 1. If this cash inflow repeat for 2 times or 3 times or 5 times, instead of enter cash flow 1 time, 2 times, 3 times, 5 times, you can just enter, okay, it repeat for 3 times, then you just enter 3 and press enter to save, and you press down arrow key. The next CO2 will show up. So this is a second cash inflow, the amount different from the first cash inflow. So again, I say this is a different cash inflow amount from the previous cash inflow. If they are same amount, you don't need to enter again. You can just using this frequency function to tell them this cash inflow repeat for how many times. Okay. And once you enter the number, don't forget to punch the enter key to save your entry. Then you place the down arrow key. They will come into the free cash frequency for the second cash flow. So if it only happened one time, the default is 1. And you can place the down arrow key to go to the next entry. So the next entry will be cash flow 3. You save your entry and press the down arrow key. They will go into the frequency for the third cash flow. So if you finish all your entry, if they come into the next cash flow, you just enter 0. And they will come back to cash outflow. So when you see they'll come out to the CF0 in your screen, then you press net present value, this key. And the screen will show I, which is your discount rate. So you enter the number for your discount rate. Then place a CPT. Then we'll solve the net present value for you. There's a video to show you step by step using the bar 2 calculator or TI-8384 on the breadboard. So if you are using a different calculator from the bar 2, please watch the video on the breadboard as well. And we will give you several in-class exercise questions using the Bar-2 calculator and show you step by step. So this is slide summarize the technique we learned so far. So net present value decision rule, as long as they can create positive net present value, then manager should accept the project. The next technique is a profitability index. Sometimes I just call PI. So as you can see, the PI formula is indicated here. You're using the present value of a cash inflow divided by the present value of a cash outflow. So actually, this is a valuation for the net present value. As you can see from the screen. On the nominator, it looks like the DCF model. So this captures the present value, the summation of present value of future cash flow. So you can see the CF1, 2, all the way to the last cash flow. So this is a cash inflow, but we're taking into account for the risk and all the cash flow as well. So this is the summation of the present value of all the future cash flow. Denominator is cash outflow, so initial investment. So it's very familiar with the net present value. The net present value just move this one to the right hand side to the top, not in the denominator of the right hand side. So use the cash outflow plus this part. Okay, so the decision rule for the PI, if PI greater than 1, then you accept the project. So what does that mean? PI greater than 1, so that means this nominator, so this look at PI equal to 1. PI equal to 1, that means the cash inflow, the present value of all the future cash flow will be equal to the cash outflow. So the PI greater than 1, that means that all the present value of future cash flow can be greater than the cash outflow, which means they can cover the initial investment and even has some value left. So it's create the positive net present value. So if you remember the decision rule in the net present value, as long as you can have a positive net present value, you accept the project. So that's why we said this is a variation of a technique from the net present value, because the decision rules are the same. The concept is the same. As long as the future cash flow, the summation of present value of a future cash flow can be greater than the initial investment, you accept the project. But instead of 0, this one is 1, because this is a ratio. Okay, so we're using the same proposal for the global wireless. And we can find for the Western European, the PI is 1.3. So you should accept this project. And the Southeastern project, the PI is 1.5. So the both project you can accept. So let's look at in the Excel template. This is the Western European project using the PI technique. So we have all the cash flow, and we're trying to find the present value of each future cash flow. And discount rate is 18%. And you can using a preset function in the Excel to solve for the PI. Okay, so this is the function. You also can just If you don't know the function, you can also simply just apply the formula. So the D16, you can see the D16 is the summation of the present value of a future cash flow divided by the cash outflow. So remember, in the formula, the denominator is positive. But in here, because it's negative, so I have to add the negative before enter this number. Okay, so the PI is a positive number because we put the cash outflow, we make it as a positive. So this ratio will be the positive. So we just simply using create your own formula, and we can calculate the PI. So this is a greater than 1, so we accept this proposal. So let's look at the second proposal in the US. So similarly, we calculate the present value of each cash flow, and we sum out together for the present value of all the future cash flow. And you can use in the function, or you can use it, homemade formula, and you can find the PI is 1.5. So the both project you should accept because they both PI are greater than 1. So this table summarizes with the additional PI. So you can see the PI greater than 1, the manager should accept the project. The PI will not give you the dollar amount and show you how much value they can create for the company. The last technique we want to show you is internal rate of return. Sometimes we just call IRR. So the simple definition is that is the internal rate of return. They can give the company with a return with a net present value equal to 0. So this is one of the most important technique, and a lot of times it's alternative measure for the capital budgeting besides net present value. So if you remember, this is a net present value formula. So the IRR is the internal rate of return on the right-hand side of the equation to make net present value equal to 0. So what does that mean? That means at least the present value, the summation of the present value of all the future cash flow they can generate from this project at least can cover this initial investment. So this part, the summation of this part of the present value is equal to the initial investment. So the IRR is this discount rate to make this present value equal to the initial investment. So what's the decision rule? So the decision rule is as long as this IRR is greater than the cost capital, then the manager should accept the project. So what does that mean? So for example, if a company borrow the money from the bank to invest on this project, so for example, the borrowing cost is 7%. And the IRR, after you calculate this IRR from this formula, and you find out IRR is 10%. So the 10% is greater than the 7%, then you should accept this project. If IRR is less than the cost of capital, then you should reject this project. To solve for IRR, you can use a formula which is we showed you earlier. You also can use an Excel template that has an IRR function available So in this Excel template, you can find the two proposals we use in the IRR. We show you can use the IRR function to help you to solve that, and very simple and easy. You also can use your finance calculator. There's an IRR function for you. And we got using our in-class exercise with the finance calculator to show you how to use the IRR function. And actually, IRR function is very closely related to net present value. So if you can understand how to use the net present value in your finance calculator, you should be easy to learn IRR function as well. Honestly, if you really want to try to solve IRR, I would not suggest you to use a formula, because you can see IRR, this is a required rate of return, is in the denominator of the on the right hand side of your equation, and you gotta solve the multiple IRR in the different function, different term. So that is very difficult to solve this equation. Most of the time, you have to try and error and many times. They can take you 30 minutes and you still cannot get the answer close enough. So to solve IRR, either using the Excel or using the finance calculator. Especially when you're taking a professional exam, the Excel template will not be available. So it's very important you learn the function in your finance calculator to solve for IRR. As IRR and the net present value are two most important technique in the capital budgeting, because you can see IRR, they take into account for all the future cash flow. They also take into account for the risk. IRR give the manager different perspective of evaluation. In the net present value, the manager produce from the net present value is in dollar amount, how much value they can create from the project. But sometimes the value can be tend to be big and difficult to present to the investor. I give you the percentage of a return can generate from the project, so it will be easier to compare the project. So both techniques are very popular. However, these two techniques not always give you a consensus suggestion. So let's look at this Western Europe project and the Southeast US project. So net present value with an 18% discount rate, you can find the Western European project create the higher value for the company. So if the both projects are positive, can produce a positive net present value, you should choose the one with a higher value. So Western European project will be select. However, in the IRR technique, you can find the Southeastern project can create the higher rate of return for the company. So which project you should choose? Based on IRR, Southeast US proposal is preferred because it's a small scale. So, but this Western European project is a larger scale than the Southeast proposal, but they can create much bigger value for the company. So when you have a conflict recommendation from between the IRR and the net present value, the golden rule is choose the net present value. Whatever net present value tell you which proposal is preferred, then choose that one. So the Western European project should be preferred, because the net present value look into additional value they can create for the company. So that is one of the important goal for the manager is to create a value for the company. So when you invest such a big amount of money into the project, you want to make sure they can create the maximize the value for the company. That's why when there's a conflict between the IRR and the net present value, go by the net present value technique. Whatever decision they suggest, that will be preferred. In this slide, we'll show you another example. So there are two projects. So you can see initial investment is 1,000 million. And for this first proposal, the cash flow did not come in until the second year. And the cash inflow gradually increased. And so you can see the year 5, the cash inflow is $1,500 million. So there's a timing issue because this project did not create a value right away or cash flow right away. If you using the payback period, probably this project will be rejected by the manager. So that's why the payback period or discount payback period normally is not preferred, because you can get out some profitable project like this. So the second proposal you can see with the same initial investment, the cash flow outflow coming right away in the year 1 and remain similar amount, but actually it's decreased cash inflow over time. And this look at the IRR and the net present value. So based on IRR, the second proposal is preferred. However, based on net present value with 10% of a discount rate, the second project is preferred. So again, which project you should choose? So if it is a mutually exclusive project, you only can accept one, you cannot accept both. Then net present value rule. So you need to go choose the project suggested based on the net present value. So the first proposal should be accepted. This table summarizes all the 5 techniques we cover in the videos. So as you can see, the IRR can provide the percentage of a return for the manager in their decision. Net present value is to provide the dollar amount for the value they can create from the project for manager or shareholder to understand the comparison between the projects. And this is summarize the decision rule. So very important, especially for these 3, the technique. Net present value greater than 0, you can accept. For the PI, if they greater than 1, then you accept. The IRR project can be accepted only if they can greater the IRR generated from the project can greater than the cost of capital. This CFO survey conducted by the Duke University by the Graham and Harvey. They interviewed with the CFO about the capital budgeting technique they use. So they find the IRR and the net present value are most commonly being used by the CFO globally. So that's why we want to emphasize again, in the capital budgeting, it's very important for you to pick up the IRR technique and the net present value. Thank you for watching and hope you enjoy.